Hi, this is Joe from the Math Perimeter, where I help to make mathematics accessible, engaging, and approachable through videos, articles, and infographics. In this video, you will learn how to perform trigonometric substitution using the sine function. For more information about this topic, please refer to the article linked in the description. In this video, we will use trigonometric substitution to evaluate the integral of x squared over the square root of 1 minus x squared dx and the integral from 0 to 1 of x squared over the square root of 1 minus x squared dx. We will start by evaluating the integral of x squared over the square root of 1 minus x squared dx. To begin, we let x equals sine of theta. The differential is then dx equals cosine of theta d theta. Substituting into the integral gives the integral of sine squared of theta over the square root of 1 minus sine squared theta cosine of theta d theta. Applying the Pythagorean identity gives the integral of sine squared of theta over the square root of cosine squared of theta cosine of theta d theta. Taking the square root then gives the integral of sine squared of theta over cosine of theta cosine of theta d theta. Simplifying gives the integral of sine squared of theta d theta. Applying the power reducing identity, we obtain 1/2 times the integral of 1 minus cosine of 2 theta d theta. Integrating gives 1/2 times theta minus 1/2 sine of 2 theta plus c. Applying the double angle identity then gives 1/2 times theta minus sine of theta cosine of theta plus c. The triangle for our substitution is, in terms of x, our solution is 1/2 times sine inverse of x minus x times the square root of 1 minus x squared plus c. Distributing the 1/2, we arrive at a final answer of 1/2 sine inverse of x minus 1/2 x times the square root of 1 minus x squared plus c. Next, we will evaluate the integral from 0 to 1 of x squared over the square root of 1 minus x squared dx. To begin, we let x equals sine of theta. The differential is then dx equals cosine of theta d theta. Under the substitution, 0 becomes 0 and 1 becomes pi over 2. Substituting into the integral then gives the integral from 0 to pi over 2 of sine squared of theta over the square root of 1 minus sine squared of theta cosine of theta d theta. Applying the Pythagorean identity then gives the integral from 0 to pi over 2 sine squared of theta over the square root of cosine squared of theta cosine of theta d theta. Taking the square root then gives the integral from 0 to pi over 2 sine squared of theta over the absolute value of cosine of theta d theta. Since cosine is positive over the interval of integration, we can drop the absolute value bars. This gives the integral from 0 to pi over 2 sine squared of theta over cosine of theta d theta. Simplifying gives the integral from 0 to pi over 2 sine squared of theta d theta. Applying the power reducing identity, we obtain 1/2 times the integral from 0 to pi over 2 of 1 minus cosine of 2 theta d theta. Integrating gives 1/2 times theta minus 1/2 sine of 2 theta from 0 to pi over 2. Applying the fundamental theorem of calculus gives 1/2 times pi over 2 minus 1/2 sine of 2 times pi over 2 minus 0 minus 1/2 sine of 2 times 0. Simplifying the arguments then gives 1/2 times pi over 2 minus 1/2 sine of pi minus 0 minus 1/2 sine of 0. Evaluating the sines then gives 1/2 times pi over 2 minus 1/2 times 0 minus 0 minus 1/2 times 0. Subtracting, we obtain 1/2 times pi over 2. Multiplying, we arrive at a final answer of pi over 4. Thank you for watching. I hope you enjoyed the video. Please like and subscribe. Thank you. See you next time.